Hey everybody, a problem tonight all the way back from 2010. It's a junior college in Singapore. And this was problem one. It was called a very difficult inequality, and I had trouble with it, figuring out the approach. But what we have here is we're given this condition right here. We're given this quotient, and we want to find the solution intervals of this expression here. Okay? Now, so it's quite interesting because the goal here is to solve this one, and you're given this one. So this is true, and this is going to create an interval. This guy right here is going to create some sort of interval, and if we can relate it to this expression, maybe we can get solution intervals for this guy. So let's get into it. Now, since this is given, we start with this statement right here. In other words, I just bring it down here. Okay, this is the given. And in a few steps, you get to this statement right here. When you subtract 8 from both sides, notice that minus 8 times 7 is minus 56. 59 minus 56 gives you the 3 you see right here. Now, something to observe that makes this inequality very easy is that 8x squared plus 5x plus 3 is strictly greater than 0 for all x. Let me write that down. Plus 3 is greater than 0, and this is for all x. You write for all x, for all real x, right up here, okay, for all x, understood to be real numbers. Now, and you go, why is that important? Well, this is just like this is a positive number all the time, so as far as inequality processing, it makes it easy. Now, how do we know that's true? Just take a look at the discriminant, folks. The discriminant here would be, let me write it directly above. I'll just write the radical that would occur when you do the quadratic formula. You would have 5 squared minus 4 times 8 times 3. But notice that's negative, resulting in imaginary number solutions. All right, so since there are no real solutions to this thing, let me just let me extend this out. So this is clearly less than 0, right? This object right here. 5 squared is 25. 4 times 8 times 3 is what? 32. 3 times 32 is 96. 25 minus 96 is a negative number. Okay, so owing to the fact that there are no real solutions to this, and this is a positive parabola that points up, we know that this is true. All right. Now, why is that useful? Well, because we get some fun. Just check out what happens here. We're actually just looking at. Again, we'll replace this entire numerator with a plus. That means a positive real number. All right. And then we're analyzing 7 minus x squared is less than 0. Well, if the numerator is always positive, that means the denominator has to be negative, right? But that leads to very quickly, and I'll just write it right underneath, I guess. That indicates that x would have to be strictly greater than root 7. Okay, because we have to force the denominator to be negative, and that can happen if x is strictly greater than root 7 or strictly less than minus root 7. Okay, so you see we've solved the given. This was, let's go back and what did we just do? This was the given inequality, and we found out the solution interval for this inequality right here. And if you want to, I can write it. You can write it like this if you want to. It's the same thing as saying minus infinity on the low side to minus root 7. Now, we haven't solved the problem yet, but we're very close. So union with root 7 to infinity. So this is sometimes called a disjunction, I think, when people are trying to teach it to kids. Okay, so there we go. All right. Now, how does that come in handy? Okay, how does that come in handy? Well, let's take a look at what happens here. Think of this transformation going from here to here, replacing x with 1 over x. Now, I could have done this introducing other variables, but I think it's pretty clear. So I'm taking I'm replacing this x and this x with its reciprocal 1 over x, and we get this statement right here. Okay, excuse me. We've already seen what happens right here with x, okay? Now we're going to replace x with 1 over x, and we get this statement right here. But if you multiply by x squared, you get the object that we're interested in. Remember, we want to find the solution intervals of this. Well, that's why I kept it in blue right here, okay? So what do we know? Well, we know that without even analyzing this statement is equivalent to this statement with x replaced by 1 over x, right? And so what does that tell us? That tells us that 1 over x has to be greater than root 7, folks. You see now, this was kind of the big deal for me to understand this. All right, you're not having to directly evaluate this thing or analyze this quotient. All the work's already been done for you up above, allowing for the substitution, right? So again, it was root x greater than root 7 up here, but now since we did the substitution, all right, into this structure that we already know what's going on, we get this. But what does this tell us? This tells us that x, if you multiply by x and divide by, you would get, let's see here, you would get 1 over root 7. Right here, let me get some space right here. Folks, you would get 1 over root 7. Now, what I did in one step, I divided by root 7, and then I multiplied through by x, so we get 1 over root 7 is going to be greater than x. Okay, like that. And also, we're going to get 1 over 1 over x is less than minus root 7. Okay, but what does that result in, folks? That results in x is greater than. Okay, if you divide through, if you bring this to the other side, okay, in other words, if you multiply through by x and divide through by minus root 7, we get x is greater than 1 over root 7, minus root 7, excuse me. Okay, now notice that 0 is definitely part of the solution set here for this inequality. If you substitute 0 in here, you get what? 0 is less than 8, right? So this leads to the fact that the solution has to be a conjunction, I guess you would call it. And so you would write your solution interval like this: minus 1 over root 7. Okay. And you're greater than minus 1 over root 7, but you're less than 1 over root 7, right? So you have 1 over root 7 like this. And this is just an open interval, 1 over root 7. Okay. Now, a lot of you might prefer, if you more explicitly, you could write this as minus 1 over root 7. Okay, is less than x is less than 1 over root 7. Now, a lot of people believe in rationalizing this. You can if you want to, but we've solved the problem. Whoops, that's supposed to be root 7 right there. Okay, this is root 7. Now, again, there's some people who, it's kind of a piddling sort of thing. But if you rationalize this thing, you would get root 7 divided by 7, right? That would be the very same thing. If you multiply top and bottom by root 7, you would get minus root 7 over 7. less than x less than root 7 over 7. You know, what do we do there? We multiply top and bottom by the square root of 7, and this is the so-called rationalizing. But anyway, this is the answer to the problem. And anyway, I thought it was kind of neat how that worked out, because you didn't have to redo the work that you did up here. You just did this substitution. You got to the expression we were trying to analyze, and then you just worked from that perspective, replacing x right here with 1 over x and the same right here. But in any event, that gets the job done. This is the solution to the problem. Here's the explicit way, and then this is the interval notation way. Thank you for viewing.